All right, let's get started. Thank you all for joining us for the first webinar of the year from BrowserStack. Really excited to see all of you, so many of you joining and from all over the world. Hope you all are staying healthy and staying safe. So I'm really excited today to have Benjamin Bischoff, who's joining us from Trivago. He's going to be talking about a very interesting topic, which is identifying code smells. So before Benjamin gets started, I'm just going to walk through a few slides, just some housekeeping and a quick introduction about BrowserStack. So we will be having this webinar today for 60 minutes. It is going to be recorded, and we will make the recording available to all of you a few days after the webinar. We will also be uploading this on our YouTube channel, so feel free to go there and check it out. You can submit questions. So we have actually a new way to submit questions. I'll cover that a little later. And we are going to be saving about 15 minutes towards the end of the webinar for Ben to answer any questions. All right, with that, let's get started. So just a quick history about BrowserStack. So we recently celebrated our 10-year anniversary, September last year. And yeah, we launched right out of a coffee shop. Ritesh and Nakala, co-founders, started BrowserStack to solve a problem that they were facing as developers, which was they were not able to test their website. It took them more time to set up an environment to test their website than to actually build their website. And they were trying to test their website on IE at the time. And they realized that developers around the world were facing the same issue. So they decided to launch BrowserStack and try it out. And they were instantly on to a huge success, 1,000 customers the first 6 months. And we have not looked back since. We've been around for 10 years. We've launched testing on real iOS and Android devices. We support testing of web apps and mobile apps. And we recently raised our Series B round at a $4 billion valuation. Some of the top brands in each of the verticals, industry verticals, are our customers. We also support a variety of leading open source projects. So if you are working on any open source project, hit us up. Just go to browserstack.com/open-source and sign up there for free access to BrowserStack if you are building an open source project. We're happy to help you out. A little bit about our scale. We have 4 million registered users. We have users who run over 72 billion Selenium commands on our platform every month. We have customers from over 135 countries, and we have data centers in 15 different locations around the world. Let me talk about our products in the interest of time quickly. So we have two main sets of products, one for helping you test your websites and web apps, and another to test your native and hybrid mobile applications. So on the website, we've got Live, which allows you to do manual or interactive cross-browser testing on real mobile devices on iOS and Android, and also on a variety of desktop browsers. So we support over 3,000 plus combinations of browsers and devices today. Automate allows you to run your automated tests on our Selenium grid. So again, you can run your tests written in a variety of languages and frameworks on our grid of real browsers and real devices. And we added Percy a couple of years ago through an acquisition. And Percy allows you to do visual testing and review. So you can, with Automate, you can test how your product or your website functions on different browsers and devices. Percy allows you to test or understand how your website looks, right? How are your different screens looking? Are they matching up to the design? Are you off by a few pixels? Are images and alignment, is that getting broken? On the mobile app side, we have App Live, which allows you to manually test your mobile apps, both native and hybrid mobile apps across Android and iOS. And we have App Automate, which allows you to run your automated tests, again, on iOS and Android real devices. We support support Appian, Espresso, XUI Test, and Earl Grey. And we have a variety of free tools to help you sort of look at taking screenshots of your website across different browsers and resolutions, look at how your website functions on different breakpoints in terms of responsive. And we added SpeedLab a couple of years ago, which allows you to look at how your website actually performs, right? So you can see the performance of your website in terms of load time, in terms of first paint time, things, key metrics like that. You can look at how that performs on different browsers and devices. All right, let me quickly walk you folks through what we're going to do for questions. So we're trying this, we're using this app called Slido. You don't need any account or anything. Just go to slido.com and enter the code number that's displayed on the screen right now, which is 16692. That will take you to a Q&A interface. You can open this up on your phone or on your laptop or desktop, and you can just start typing in your questions. And everybody else will be able to see questions, on the same page, and you can basically upvote and downvote. So, we make sure that we try to address as many questions as possible, but we also try to address, the most popular questions also. And you can make sure that what you're asking has not already been asked, right? You can just upvote a previously asked question. So I'll give everybody a second to do this. If you could just go to slido.com, enter 16692. And just type in your questions. And again, feel free to do that throughout the webinar. And then Ben and I will try to address as many of those in the last 15 minutes that we've saved for the webinar. I'm just going to give everybody a minute. Awesome. The team is going to be putting up also a Q&A, a quick poll, on the Zoom interface. It will help us understand, what kind of content and what kind of topics you're all interested in. So please tell us, where does your organization stand in terms of test automation maturity, and what are some of the major areas of improvement you want to focus on in your test environment? So, yeah, just take a minute to answer that poll. All right, let's dive in. So I'd love to introduce you to Benjamin today. Benjamin works as a test automation engineer in Trivago's core QA team. He's the author and maintainer of 2 open source projects for Cucumber BDD, parallel test execution and reporting. He's spoken with BrowserStack before, and he's got some great content on the internet. You can check out his blog, and I'm really happy to have him join us today and talk about code smells. Over to you, Benjamin.
Hello, everyone. Let me share my slides. I hope everyone can see them.
Yep.
Perfect. So thanks a lot, BrowserStack, for organizing this and for having me. I'm really excited to talk about this topic because it's a topic that's pretty close to my heart concerning clean code and code craftsmanship. And before we start with the topic, I was introduced right now, but I want to say some more words about myself. As you heard, I'm a test automation engineer at Trivago. I've been here for 5 years, roundabout. I have 7 years of software development in test experience, and in total, I have more than 20 years of development experience, and that's probably why this topic interests me so much. I can be reached on Twitter. You can give me feedback whether you like this or not. @BischoffDev is my handle, and softwaretester.blog is my website where I publish occasional articles. A little disclaimer, this webinar is going to be rather code heavy, and it's going to be all Java. I'm sorry if you don't code in Java, but this is the language I use daily. So if there are questions coming up about the code examples, I'm more qualified to answer them than if we would do that in another language. And please note that this is about identifying code smells only. It's only a first step towards clean code, but it's not the only step. The identification of the code smells is important. How you would deal with all the code smells in detail, that would be too long. Maybe we can do a follow-up in the future, but I will also tell you what you can do when you find some code smells. For me, a starting point for this was an essay by Rody Green that's called How to Write Unmaintainable Code. It's a rather tongue-in-cheek essay, so it tells you a lot of ways to make your code as bad as possible. But still, all those tips that are in there makes you really think about your own code. So I would highly recommend you checking this out. By the way, whenever I have URLs on my slides, I also put the QR code in the top left corner, so you can just scan it and go straight there. So that's one of the quotes from the essay that I really like. In the interest of efficiency, avoid encapsulation. Callers of a method need all the external clues they can get to remind them how the method works inside. And the other tips in there are along this line. So let's see, what is a code smell and where did the term come from? It all started with a book. It's called Refactoring, Improving the Design of Existing Code, written by Martin Fowler together with Kent Beck. And it was published in the year 2000, so it's 22 years old already. And that was the first use of the term code smell. Kent Beck actually coined that term. Before that, what we're talking about here was more known as an anti-pattern, but this is not really fitting. You will see why in a second, because I have a quote here from Martin Fowler. He says, a code smell is a surface indication that usually corresponds to a deeper problem in the system. But, and that's the important point, you have to look deeper to see if there is an underlying problem there. Smells aren't inherently bad on their own. They are often an indicator of a problem rather than the problem themselves. And that's really important. If you spot a code smell, that doesn't mean that you have a problem. It depends on the scope of your code. It depends on the context. It depends on the lifetime of your code. If it's a permanent solution, if it's something that goes to production or something that's just temporary. And why should you care about code smells at all, especially when you don't do any development yourself? Simple answer is code reviews. Whenever you are involved in code reviews, whenever you speak to developers on a regular basis, it's invaluable that you speak a common language. And it's really, really good if you can point out issues in the code and name them correctly, so developers can understand and act accordingly. And when you combine this ability to spot code smells with software design patterns, with software development principles like the solid principle, you have really great tools to make your code really clean. And if your code is really clean, it's better testable. And if it's better testable, it's more maintainable. So it's more future-proof and you can refactor code much more easily. There is a problem with the book, Refactoring. They mention a lot of code smells, but they don't categorize them. That's why I use for this webinar the taxonomy of code smells that two people from the Helsinki University of Technology wrote about in a paper. I linked it here. It's Mika Mentala and Kasper Lisinius. They put all the code smells into categories, which makes it much easier to talk about them. And I will actually go through all the categories there are and all the code smells. I created code examples for all of them. And I will also point you to my GitHub repository where all this code is available that I created for this talk. That is everything we will go through. Hopefully, it won't take too long, so we have some room for questions. So let's start directly with the first one. And the first category is bloaters. That is something that is too large to handle. You will see what that means. The first one I want to show you is a long method, a method that does too much. And I really hope I created code examples that are easy to follow. I will also point out the relevant lines here. So in this example, I have a webshop class, and this webshop class has a method called saveCustomer that you pass in a customer and you expect it to be saved, like the method name suggests. And it actually does that. But additionally, it returns an HTML representation of the customer, which is something that the method name does not imply. It just says save customer, you expect it to save a customer, but it does something else. So a long method doesn't necessarily mean that you have a lot of lines of code, but it can mean that the method is just doing too much, and too much that is out of its own scope. The same can happen with classes. You can have large classes, so classes that do too much. Sometimes they are also called God classes, so classes that do everything, like in this shopping cart class. And we actually have methods here that belong to a shopping class, shopping cart, sorry, add product and remove product. That is perfectly fine. But if you look at the other methods that are in here, you have checkout, you have enter voucher code, and you have contact support, which is again out of scope of this class that belongs more to the web shop itself. So you probably get the idea of what the bloaters category means. It doesn't mean you have a lot of code. It just means you have some codes that does too much. The next one is tricky. It's called primitive obsession. And that is about using primitive data types where other data types would be more appropriate. Like here. And I say it's tricky because this is something that heavily depends on the context. So this can be perfectly fine in your solution. And I know I have used something like this myself. In this case, you have a customer. It's a record in Java, which is the new way of defining value objects. And you have properties of this customer: name, age, address, city, zip code, and country. And you might think at first glance, this is fine, but actually it isn't, because you can have a negative age. You can have empty addresses. You can switch around the zip code and the country because both are strings. So you don't have any validation of the data, which you could have if you created specific data types for everything. So an address data type, a city data type that has built-in validation, a zip code data type, which needs a lot of validation for the zip code to be valid. And what you could also do is separate the address from the customer, because the customer could also have multiple addresses. This is actually another code smell that I will show you later. Then, when you have a method that is a long method or a long parameter list, that means that it accepts too many parameters. And this is also something I'm guilty of. because I have done that before. Like here in this imaginary tool class, cat tool class, there's a method called calculate result that takes 5 parameters, a base value. It takes a Boolean that is called ismetric, another Boolean that is 2D, and so on. So the call to this method looks like this. And you can immediately see that there is a problem. If you don't have a smart IDE that shows you what those parameters are, you have no idea what that means. Calculate result 13 false, true, -1 null. And this is why you should strive for keeping the parameter list of methods really small. Also, another problem, if you have a lot of parameters, that points to a method that branches out a lot. So especially when you have Booleans, that points to if-else branches in method. And this is a nightmare to test. The more parameters a method accepts, the more unit tests you have to write. The next one in the bloaters category is data clumps. It's grouping data together that should not be grouped. We have our old friend, the customer again, and we have data that belongs to the customer, like last name, first name, middle name, and salutation. But here you also have street address, city, and state, and even data that is out of scope, like is employed or is homeowner. So all this data always gets passed around when you pass this customer object around in your code, which is probably not needed. Also, there is the problem again, if the customer has multiple addresses, that is not reflected here. So it definitely makes sense to extract out an address class and maybe something like employment status and home owning status or something as a separate class. So those were the bloaters. You see that it doesn't really take too much time to go through the code smells in a category, but I hope you get the idea of what can be problematic here. So without further ado, let's go to the next one. That is object-oriented programming abusers. That means missing object-oriented design possibilities. You could say that, well, if you use an object-oriented language, you don't have to program in an object-oriented way. And if you don't do that, if you don't use those advantages that those languages give you, you get the following code smells. Switch statements is a classic. It's a method that branches out too much, and that is closely related to the long parameter list that I showed you before. Like in this vehicles class, you have a strange little method called number of wheels that you pass in a vehicle name and a number of vehicles, and it returns you the total number of wheels. So like for a car and a 2, it would return 4 by 2, so 8 wheels. But it's really evident that this is not a nice way to do it, because whenever you want to add another vehicle, you have to extend this method. Also, on a side note, it's really not a good idea to pass in those vehicles as a string. So each vehicle should definitely be a class, and they should definitely be extended from a base vehicle or implemented a vehicle interface or something like this. But you can see that this is not using the object-oriented paradigms that the language offers you. Temporary field is another tricky one because it heavily depends on the context of your code. Like in this rectangle class, there you have the side A and side B of a rectangle that you can set from the outside with the set side A and set side B methods. But what is this data actually used for? And it's only used for this method, get area size, that returns the side A multiplied with side B. So you have a lot of boilerplate code. You have those fields, side A and side B, that are only used in this one method. So it might be better in this case to pass the side A and side B directly to the method. Also, if you do it like this, you have to make sure as a user of this get area size method that you set side A and side B before that. Otherwise, you get 0 as the result. Well, this one I had to look up what refused bequest actually means. And a bequest is something that you pass on to someone. So in the case of code smells, it means passing unneeded behavior to siblings. And that looks like this. Imagine you have an interface for animals. And when you start your program, you think, okay, animals speak in some way, so I will add the contract, the method speak that all animals should support. So you implement a dog and you override this speak method because you have to, since it's specified in the interface. And this speak method just prints out woof. That's the sound the dog makes. But then you have a fish, and this fish probably cannot speak, but it has to implement this method. And in this case, it's an empty method. So you pass this behavior to the sibling fish, but a fish cannot do anything with it. So it has to override it with an empty method. And this is really ugly. Alternative classes with different interfaces is a classic. And I stumble across this multiple times, both in my own code and in other people's code. It's confusing naming of similar functions. Like in this shapes example. You have a circle and you pass in a radius and you get the get area size method that calculates the area of this circle. And you have a rectangle that has two sides as before, and it does the same thing, but it calls it get surface size. So this can be really, really confusing if you have two shapes that should be derived from the same base type and implement get area size or get surface size method, but not mix up the naming. Naming is one of the most important things in programming that I know. If you name things correctly, you are well on the way to clean code. That was the object-oriented programming abusers. I hope you're not bored yet. We have 3 categories to go. So let's go to the change preventers. This is something that hinders further development. And the first one is divergent change. It's changes across methods. This is a rather stupid example, but it's an animal class, and you have a method get Latin name. So again, like the vehicles example, you pass in a name of an animal, and you get the Latin name for this animal. And you have another method get number of legs that does essentially a similar thing. You pass in a name of an animal and it returns how many legs it has. The problem here is that whenever you want to add or remove an animal, you have to do it in two places. And this is a very small example, but in real world programs, this can happen across several more methods. And this also can happen across classes where it's actually harder to do correctly. And the term for it is shotgun surgery. This is changes across classes. So here we have the same functionality as before, but in two separate classes. One is the classification class and the other one is the body parts class. But we have the Latin name method again that accepts a name of an animal. And we have in the body parts the get number of legs method. And typically those two classes would be in separate files. So if you don't have a very smart IDE that tells you or that makes those changes and those additions for you, you have to keep track of those yourself. That means if you want to add animals, if you want to remove animals, you have to go through all your classes and do the same thing over and over. This was a very tricky one to find an example for, parallel inheritance hierarchies. This is about inheriting parallel interfaces in parents and children. And hopefully this example is clear enough. If not, please tweet at me or ask about it so I can find a better one in the example code. We have two classes here, a bird and an egg. And a sparrow extends the bird. So far, so good. So here we are using object-oriented programming principles and extending the bird. This is where it gets problematic because here we extend an egg to be a sparrow egg. And we have the lay egg method of the sparrow that lays a sparrow egg. And the problem with this is whenever you want to add a new bird, you have to do, you have to extend another bird and another egg. So have two parallel hierarchies that you have to keep in sync. That was all in the change preventers. So we are speeding through those. I hope it's not too fast for you, but if you have any questions in the future, you can, like I said, tweet at me or ask them after I finish presenting. But now it's time for the dispensables. Those are unnecessary things in your code that can be removed. And a classic is a lazy class. Again, this specific one is something that can be desired in your code, but it can also point to a deeper problem in your code. This web shop checkout class has one method, checkout, and that's all it has. So you have to ask yourself when you see something like this, do I really need this class? Because if you have very, very, very small classes and a lot of those classes, it can get really cluttered and really confusing. On the contrary, this can also lead to more clarity. So this is a very tricky one to investigate if this is a problem or not. DataClass, we had that before in another code smell example, a class that holds only data, but not its associated logic. Here we have our old friend, the rectangle again, with a side A and side B. And that's all it has. It just holds the data for side A and side B. But later in the code where you actually use this rectangle, you calculate the rectangle area. So a functionality that should be in the rectangle itself, returning its own area, is extracted to somewhere else where it doesn't necessarily belong. So it would be smarter in this example to have this inside the rectangle itself. Duplicate code is something that probably every one of you who coded before has stumbled across, having the same code multiple times. So there is a principle that's called dry, don't repeat yourself. And this is something that can be applied here. In this case, we have an add customers and a remove customer method. And in this case, I wanted to print out the customer list after I add or remove a customer. So this is the code to print out the current customer list after I add a customer. And I wanted to do the same thing for the customer list when I remove a customer. But you can see even without the help of an IDE that this is the exact same block of code. So if I want to change this, I have to do it again in 2 places. And maybe I forget one place and then they're out of sync and are not doing what I want. So it would make way more sense to extract this out into one special dedicated method that prints out the customer list for me. And then just use this, because then you only have to make a change in one place. That code is something that modern IDEs always point out, which I'm very glad for. That is code that can never be reached. And that happens here. If you don't have an IDE and you just look at this code, it might not be apparent when you first see it. But here is a method that gets pi, so the number pi, and I created this method because I didn't know that Java supports math.pi already. So you don't need this method anymore, and I replaced it with math.pi, but now this getPi method is never called. So it's dead code, and dead code should always be deleted. Especially when you use a versioning control system, it doesn't hurt to delete dead code because you can always retrieve it later if you need it. Also, I have more dead code inside the dead method. It's a print statement that says returning pi, but this is also never reached even if the getPi method is used, because the return of the value ends the method before it can print this line out. So we have dead code inside of dead code. Speculative generality. That's one of my pet peeves in coding. That is making code future-proof without the need. Let's imagine you have a printer in your office, a laser printer, and you want to write a program for it. A program that turns it on or off and that prints some text to it. But here you decide, maybe I will buy a new printer in the future, so you create an interface for the printer. An interface that has the methods print and turn on or off. And you have your laser printer that implements your printer interface. The problem with this is that you now have 2 classes, even though you don't need them. And you have an interface, even though you don't need it, because you just have one single printer. You can always refactor this whenever you get more printers. But doing this before it's needed leads to confusion. It leads to more tests you have to write. And it's just, I think, in my opinion, not a good idea to do that, because you can just lose yourself in trying to come up with things that might happen in the future in your code. That was the dispensables. So unnecessary things to remove from your code. And that is probably the easiest code smell to fix. And then we have the couplers. And the couplers, that means that you have too much or too little coupling between classes. And a true classic of this is feature envy, a class implementing a feature that another class should have. We had kind of like this before in another code smell example with the rectangle, where you calculate the rectangle area outside of the rectangle itself. And here is another example. We have an address class, which is good, like we learned. We have the street, the city, and the country. And we have a user that has an address. But the user has the method getAddressString that returns a string representation of the address. And this should be definitely a part of the address itself, because it just uses properties of the address and constructs a string. So if you want to have the same address string in another class that has an address, you would have to duplicate this code again, but not if it was part of the address class itself. I really like this name for this code smell. It's called Inappropriate Intimacy. It's two classes that know each other too well. Like here in this books and authors example. You have a book, and the book has an author. You see it here. The book knows its author, but also the author knows its book, which is totally unnecessary in this case. But I have seen those cross relationships come up again and again. Message chains can be good, but they can also be really, really bad. It's methods that return objects that return objects that return other objects. And here it's not necessary that you look at all the code. It's only necessary that you look at this line. Here you want to get a shelf by an index, and from this shelf you want to get a product by an index, and from this product you want to get the description. So you have shelves get 0 as the index, dot products dot get 0 as the product index, dot description. So this is a long line, and in this line a lot can go wrong. You can have null pointers, you can have index out of bounds exceptions. So be really, really careful when you rely on this method chaining. And the middleman, I think that is also the last one. A class accessing another class on its behalf. Here's our customer again, and the address of the customer. And instead of getting the city and the address directly from the address class, we have the middleman customer that when you get the city, it asks the address to give him the city. And if you get the street, it in turn calls the street method on the address record. So it does things that it shouldn't do. And instead of this, you should get the address from the customer, and then from the address, get the information you need. And with this, we already went through all the code smells there are and all the categories there are. And it's really, really vital that you get familiar with those smells. You don't have to know the exact name. You don't have to know exactly what might be wrong with it, but it's more about getting the sense when you see code that you think there might be something wrong. Like I said, the example code for everything is here in my repository, Bischoff dev/codesmells on GitHub. And I want to spend 2 or 3 minutes, if I can, to go through some general guidelines of when to fix code. And my guideline is fix it right away when you see it. Because there is something that's called the broken window syndrome that refers to a house where a window is broken. And if this window is not fixed in time, there will be people who say, oh, this window is broken, let's break another one. And then you have garbage in the house and rats and a lot of stuff. So instead of waiting and relying on someone to fix something later, do it right away if possible, of course. YAGNI, that refers to the premature future proofing of code. That stands for you aren't gonna need it. So this is about wasting time with future requirements I talked about, but that's the word for it, YAGNI. We have the campground rule, which means always leave the campground cleaner than you found it. That's kind of like the broken window syndrome. If you see something that can be fixed in the code, just do it, especially when it's your own code. I've seen so many developers, including myself, implement something and saying, okay, it works for now, I'll clean it up next week, but later never comes. You will not do it. So do it correctly the first time and everyone is happy. And like I said, code reviews is a really good place to point out smells before it is too late and before they get merged and maybe pushed into production. So it's always a good idea to do thorough code reviews with multiple people. Because if you implement something yourself and you review it yourself, you will not find it. Some more resources. Of course, the refactoring book I pointed out before. We have the catalog of refactorings. That's a website belonging to this book by Martin Fowler. And he lists strategies to overcome code smells, but not under the nice categories and names we used today. Instead, there is another website called Refactoring Guru that uses those categories and the whole code smell taxonomy and recommends refactoring methods, which is really nice. Then there are other books that point you to further things you can do, like Clean Code by Robert C. Martin from 2009. It lists a lot of clean code principles that you can apply to not run into code smells. And also a really good book that everyone who's into development should read, Design Patterns, Elements of Reusable Object-Oriented Software from 1994, but it is still super valid today. And it also has a lot of strategies for clean code. And with that, I thank you a lot for sticking around. I hope that my examples weren't too hard to understand. And thank you again, BrowserStack. If you have any feedback, you can reach me on Twitter at BischoffDev or check out my blog at softwaretester.blog. Thanks a lot.
Awesome. Thanks, thanks, Benjamin. That was a funny presentation. I love the terms that you use for code smells. The intimacy one and the dead code and dead codes is pretty funny. Awesome. We have a lot of questions. Ben, do you mind stopping your share, and I'll just share my screen.
All right.
You can. Thank you. Folks, before we start the Q&A, we're just throwing up a quick question poll on the in the webinar. Just let us know if you would like somebody from BrowserStack to get in touch with you, just regarding testing and getting a test running on BrowserStack. So awesome. While you answer that, let's go through some of the questions. Benjamin, these are the ones that have been voted the most popular. So let's try to go through these one by one. Excuse me. All right. So do you have any tools? I think you talked about peer reviews. Any other sort of suggestions here?
Yeah, I mean, there are also automated tools like SonarQube for pull requests, or many other tools that can be integrated with CI/CD systems. But I think the most valuable tool is your own brain and your own judgment. And also what's really helpful is modern IDEs, because issues like code duplication and dead code and things like that, they are pointed out already, which makes it really nice. And also refactoring code is much, much easier if you have a good IDE.
Got it. Got it. Okay. I think you answered the Sonar question.
Yeah, I would also love to show you how to fix each code smell, but there was just not enough time to do this for this webinar.
Got it. Maybe an idea for a future blog post.
Absolutely, yeah.
Awesome. How do you go about refactoring? I think you sort of talked about this a little bit. How do you identify code smells? Then you talked about this. You can skip these two. What about this one? Is it better to have more methods that accept less parameters?
I would say yes. It's always good if methods accept less parameters. For testability, it's way easier if you have a method with 1 or 2 parameters than to have a method with 10 parameters. And that's what I wanted to point out with the long method and long class. It's not about the lines of code. It's about understanding the code and having good naming, having clear boundaries, having clear, just having small scopes for everything, small, easy to understand scopes, because in the end, code has to be understood by humans. So for a computer, it's completely irrelevant if you have 50 lines of code or 5,000 lines of code. The key point is that you have to be able to understand your own code in half a year.
Yep. Got it. The next one is around mobile testing on BrowserStack. I'll just take a quick stab at that. I think, do we do it in real? I mean, do we get 100% UI accuracy? Yes, you do. We host only real mobile devices, so both across iOS and Android. So whatever testing you do, you are actually getting connected to a real device. So it is 100% accurate. All right, let's keep going. What would be a solution be to make parameter list smaller and longer?
Well, that's easy to say. You can either create multiple methods that call each other, or you can instead of passing like very small parameters, you can create a custom class that holds all the parameters you want to pass to the method. So that there are actually a lot of strategies to make this smaller. But the key point again is to keep the scope small so you don't do too much in such a method.
Got it. Yeah, I think the slides, Ben, would it be possible for you to share this? I mean, we'll upload the video, obviously, of the webinar. Yeah, maybe we can connect offline and we figure out how we can share that. Or
but for sure, I can share the slides in some way.
Awesome. Any news regarding testing on Android TV devices? Conrad has asked this question. I think, Conrad, I think this is something that we are looking at. I think definitely reach out to us. We'll share sort of more details as soon as we know more around this. Thank you. Okay, great feedback. Let's keep going. Sorry, this question around the book, an author example.
Regarding the cross-relation book author, wouldn't that relation help to get the data of books from the author and vice versa? Yes, it would. But at the same time, you have this cross-relationship that you don't really need depending on how your code is built. I would probably build this differently so book and author are independent of each other, because a book can have multiple authors, an author can have multiple books. So this direct cross relationship doesn't really make so much sense.
Got it. Performance testing for mobile apps. No, we don't provide that quite yet, but you do get profiling data when you do use App Automate on BrowserStack. So you can use that as a proxy for understanding the performance. Okay, let's keep going. Skip that one. I think people want all the answers to your code smells. All right. Parallel inheritance.
Some cases we might need to add an interface for a single class so we can mock it for unit tests. Is that a code smell by itself? Again, it depends on the circumstances. I think here it's not necessarily code smell.
Got it. All right, last couple of questions, Benjamin. Let's keep going.
When identifying code smells, are both functionality and style taken into account? Style in terms of code style? Because that should...
I'm guessing so. I guess it means like indentation and I don't know, like maybe, I don't know, I'm guessing.
That could be. If it's the case, there are automated methods that can fix the indentation so everyone can do their own code style, and when you check it in, it's all formatted correctly. But apart from that, it's always good to adapt to the style of the team you're in. So if you have an existing code base, you shouldn't change the code style of something you add.
Got it. All right.
Let's see, in the example of duplicate, don't you think that creating one method to add and remove a customer would basically create a function that's doing too much? The solution I was suggesting was not to create a method that adds and removes a customer. I wanted to extract out the bit of code that prints out the list of customers. That was the code duplication. You should definitely have that separate when you add and remove a customer. That should be two separate methods.
Got it. I think this one is interesting. What about functional programming?
That's a really interesting question. I don't do much functional programming, so that is probably a question for another expert and another webinar. That's
Awesome.
not my area of expertise.
Got it. No worries. I think Ben, we can call it a day. Thank you. I think that was a really enjoyable webinar. I was taken back to some of my early classes in object-oriented programming with Java. It's great to sort of refresh, and then I love the names of all the code smells, and I think our audience really enjoyed it too. So thank you for taking the time to walk us through all of that.
Thank you for having me, and have a nice day wherever you are.
Thank you, Benjamin, and thank you all for joining. As you quit the webinar, you will get a quick NPS survey. Just let us know your feedback about the webinar, how you liked it, if you liked it or not, and what we can do next time to improve. So thank you all, and have a great day. Thank you, Benjamin. Bye.